I am a good teacher. These students are going to learn. Let's have a good day. Oh, you're already here. That was funny. Huh? Oh. So, welcome to my class. My name is Slybot, and I will be your new teacher. Oh, I think it's a little bit loud. Could you keep it down, please? Yes, that's much better. Like I was saying, I'm Slybot, and I will be your new teacher. Let's get ready because it's math time. Welcome to the first class, and our first concept will be 1.1, Understand Ratios. Please make sure to write down good notes because all this information might just show up in a quiz. Let's get ready to work. In mathematics, a ratio indicates how many times one number contains another. For example, if there are 8 oranges and 6 apples in a bowl of fruit, then the ratio of oranges to lemons is 8 to 6. Similarly, the ratio of lemons to oranges is 6 to 8, and the ratio of oranges to the total amount of fruit is 8 to 14, 14 being 6 plus 8, the total which is 14. In our first example of a word problem, we will have Vicky who's bought 5 vegetables for every 7 fruits she's bought. How could you write the ratio of the number of vegetables to the number of fruit? Well, this could be represented the number 5, the word 2, and 7. This can also be mathematically represented by the number 5, a colon, and the number 7. This is also read as 5 to 7. And finally, it could also be represented as a fraction, 5 over 7. In our next example, at a football game, there were 4 times as many fans for the home team as there were for the visiting team. What was the ratio of home team fans to visiting team fans? Well, the key word here is 4 times as many, which means for one visiting team fan, there are 4 times more home team fans. So this can be written again with the number 4, with the word 2, and the number 1. The number 4 with a colon and 1, or simply as a fraction, 4 over 1. In the examples before, we could represent ratios as if they were fractions, but there are differences between both. Ratios shows 2 quantities in a relationship, can represent a part-to-part relationship as well as a part-to-whole relationship. Fractions can be added or subtracted. They result when a whole is divided into parts and can be graphed on a number line. A family took a walk to the pond in their community. They saw 10 geese and 8 ducks. This can be represented by a part-to-part ratio, which would be 10:8, which represents 10 geese and 8 ducks. We can also flip those numbers and represent it 8 to 10, which is 8 ducks to 10 geese. We can also make this ratio part to whole. It would be 10 to 18. That would be 10 geese for the total that we saw, which is 10 plus 8 ducks, which is 18, 10 to 18. Another way we could represent it is a whole to part ratio. Again, the whole would be 10 geese plus 8 ducks, which equals 18, to 8, which this represents 8 ducks, 18 to 8 ducks. In our next example, in a survey, 8 out of 10 dentists recommended a certain kind of toothbrush. Write a ratio that compares the number of dentists who did not recommend the toothbrush to the number of dentists who did recommend it. For this example, we have to figure out how many dentists did not recommend a toothbrush first. So if 8 out of 10 did, we would have to subtract 8 out of 10, which leaves 2, and 8, we have been told, did recommend a toothbrush, so the 2 others did not. So in this case, we can write 2 to 8 would be the ratio. We can write it down with the number 2, with the word 2, and the number 8. We can write it down with the number 2, a colon, and the number 8, or again, like a fraction, 2 over 8. For our next example, the following statements are facts about U.S. students who graduated from and who dropped out of high school in 2012. Which facts give numbers that could be represented with a ratio? About 2 out of 3 graduates began college later that year. 2 out of 3 is a ratio, and the keyword is out of. About 1.1 million graduates did not attend college later that year. About 1.1 million does not give enough information for it to be considered a ratio. It's just an estimate of a number. For it to be a ratio, we have to have a comparison between two specific numbers. Out of every 10 graduates enrolled in college, 6 were attending 4-year colleges. So out of every 10, 6 were attending 4-year colleges. That is a specific amount for each option. So that is a ratio. Between the 2011 and 2012 school years, 370,000 students dropped out of high school. That is a specific number, but it does not give us a comparison to anything else. So, again, it cannot be considered a ratio. Among the graduates, 6 men were attending college for every 7 women attending college. Again, 6 men for every 7 women is very specific, and it does give us a comparison between 2 parts in a whole. So this, again, is also a ratio. Jenna is designing a beaded necklace. She will string jewels at a ratio of 2 red jewels to 4 brown jewels. She needs 24 total jewels to complete her necklace. Complete the table below based on this ratio to show how many jewels of each color Jenna needs, which will be shown in the last row. We are given a table, and this is the first true mathematical problem that we have to understand. In the first column, we see number of red jewels, which in the word problem we are given that is 2. After we put in 2 red jewels in the necklace, we will also put brown jewels. And this is the next column, which is the number of brown jewels. And again, we're given the number 4. In the last column, we have the total number of jewels, which is simply 2 plus 4, which is 6. 2 red jewels plus 4 brown jewels equals a total of 6 jewels. In this table, we have only 3 other numbers that are given. For each row, we are given 1 number. For that row, all we need is that number to understand what the other 2 numbers should be. And we take the first row, which we're given the number 12. So, in this example, all we have to do is see the example in the first row, which again, the total number of jewels is 6, and we need to figure out what the number of red jewels to the number of brown jewels would be if we didn't have a total of 6 jewels, but 12. So we just look at the number 6 and the number 12 for now. To get 6 to turn into 12, what do you think we have to do? Well, the simple solution would be 6 times 2 equals 12. It's simply double the amount. So 6 times 2 equals 12. We can then apply that same formula, 6 times 2 equals 12, to figure out how many red jewels and brown jewels it should be. 6 times 2 equals 12. And then 2 times 2 equals 4. The same way we can figure out the number of brown jewels, which would be 4 times 2 equals 8. And that would finish the first exercise. But we still have 2 more rows to go. In the next row, we have the number of brown jewels, not the total number of jewels. But because it is a ratio and the ratio stays the same, we can basically apply the same rule. 4 times what equals 12? We just have to figure out that number, that magic number that makes 4 times equals 12. In this case, 4 times 3 equals 12. And in the same way we figured out the top row, or the middle row with 4, 8, and 12, we can figure out the rest of the other boxes in this row. 2 times 3 equals 6. 4 times 3 equals 12, which is already given. And 6 times 3 equals 18. And now we're almost done. And for the last row, we're given the number 24, which is the biggest number, but is not harder at all. Only because it's a bigger number makes no difference. All we have to do, again, is look at the first row, and the total number of jewels is 6, but we need to figure out for 24. We only need to figure out for that, how much do we need to multiply 6 times what to get 24? In this case, 6 times 4 equals 24. And that is our magic number. All we have to do now is multiply 2 times 4, which equals 12, and 4 times 4, which equals 16. And we have filled out our table. A local garden center recorded the number of each type of fruit tree sold last month. In this example, in the first column, we have the type of tree, which are apple, apricot, cherry, pear, and plum. In the next column, we have the number of fruit trees sold, which is 14 apple, 8 apricot, 16 cherry, 28 pear, and 12 plum. Now, write the ratio that compares the number of apple trees sold to the total number of trees sold last month. So, keyword is apple trees and the total number of trees sold last month. The way we can do this is, well, we look first at the tree type, which is apple, and the number of trees sold is 14. That is pretty simple. The next thing we would have to add for the total number sold, which is simply 14 plus 8 plus 16 plus 28 plus 12, which equals 78. So the ratio is 14 over 78. Finally, we need to figure out all the rate language that we have used. Our first example, there are 3 red marbles per 2 blue marbles. The keyword here being per, the 2 specific numbers, which is 3 and 2, which uses rate language. For every 3 red marbles, there are 2 blue marbles. Again, for every is our key word that uses rate language. 3 marbles and 2 marbles, which are the specific numbers and parts in a whole that we are comparing. And finally, there are 2 blue marbles for every 3 marbles. And again, we use for every in the use of rate language. We can also make comparisons without using rate language. In the next 2 examples, the comparison between red and blue marbles is 3-2. That does not use rate language, even though it almost seems to make sense as being a ratio. The next one, red and blue marbles have a ratio of 3/2, which again, it almost makes sense that it is giving us a ratio, but it's not being specific enough. So it does not use rate language, even though it uses the word ratio, and in the first example, we also use comparison. In our next example, 17 out of 24 students in a class say they study every night. Use this information to determine the ratios below. We will need to figure out students who study nightly to the total number of students, students who study nightly to students who don't study nightly, total students to students who don't study nightly, students who don't study nightly to students who study nightly. This might seem a little bit complicated, but we only have to go step by step. So in the first one, we consider students who study nightly. That is given with the number 17 out of 24 students in the class. They say study every night. So it is simply 17. And the total number of students is also given there, so it's 17 to 24. students who study nightly to students who don't study nightly. Again, students who study nightly is given, so that's 17. We need to figure out who's the students who don't study nightly. So we only need to take the total, which is 24, minus the students who study nightly, which is 17. 24 minus 17 is 7. So the ratio would be 17 to 7. Now, total students to students who don't study nightly. The total number of students, again, was given, which is 24. And the students who don't study nightly, we figured out in the question before, which is 24 minus 17, which is 7. So the ratio would be 24 to 7. Students who don't study nightly to students who study nightly, again, we figure out by 24 minus 17, which is 7. And the first number that we were given was 17 of the students who study nightly. The ratio would be 7 to 17. Ratios can be used to compare quantities. 10 out of 25 students play sports. Out of being the key word there, and 10 and 25 being the specific numbers we are comparing in a whole. The number of 6th graders who study every evening compared to 7th graders is 2 to 3. Compare 6th graders to 7th graders, and we are also given the ratio 2 to 3. For every student with a dog, 2 do not have a dog. So for every student, which represents 1, have a dog, and 2 do not have a dog. That is also very specific. It uses the word for every, which is our keyword, that represents a ratio. In our next example, one of the differences between ratios and fractions is that a fraction can be modeled on a number line, and ratios cannot. Using what you know, match a model of a number line for each of the following numbers, which are fractions, but not ratios. In this example, we start on the far left, 1 over 3, and on the far right, 1. What number could possibly go in the middle of those two? Well, because 1 is a fraction and 1 is a whole, the easiest way to figure out this question would be to make all the numbers fractions. The way we do it would be to make 1 a fraction that has the same denominator as 1/3. The way we do that would be representing it by 3 over 3. And then it becomes quite easy. If 1/3 is onto the left and 3/3 is onto the right, the one in the middle, an obvious number, would be 1, 2, 3. 1/3, 2/3, 3/3. That easy. If you have a pattern of 2 red beads to 1 blue bead, what are the next 3 extensions of this ratio? Red beads on column 1, blue beads in the middle column, and extension in the last. Again, we're giving the first numbers, 2 red beads, 1 blue bead. The first natural extension would be just to multiply 2 times 2, which would equal 4. Similarly, because we're in the same row, 1 times 2 equals 2, and we are finished with our first extension. We continue for the next 2 extensions the same way, just multiplying by 1 number more. So 2 times 3 equals 6, 1 times 3 equals 3, 2 times 4 now equals 8, and 1 times 4 equals 4. If you have a pattern made of 2 red beads to 3 blue beads, how many of each would you need to extend the pattern to 15 total beads? 25 total beads, 35 total beads. And again, we can make a table for this. In the first column, we have red beads, which we are given is 2 to a ratio of 3 blue beads. And the bead pattern for that one would be a total of 5 beads. Now the question asks 15 beads, and all we have to figure out is 5 times what equals 15. In this case, 5 times 3 equals 15. And to figure out how many red beads or blue beads we need, we just multiply those numbers by the number 3. So 2 times 3 equals 6. 3 times 3 equals 9. And then we're asked how many would it be for 25 total beads. And again, we just repeat figuring out the multiplication of the number 5 to how much does it give us 25. And in this case, 5 times 5 equals 25. So to figure out red beads and blue beads, we just multiply those numbers with the number 5. So 2 times 5 equals 10. 3 times 5 equals 15. And finally, we are asked for 35 total beads. And again, we look at the bead pattern and we start with the number 5. 5 times what equals 35? And in this case, 5 times 7 equals 35. So again, we look at the red beads column and the blue bead column and we multiply. 2 times 7 equals 14 and 3 times 7 equals 21. And we have completed the table. And with that, we conclude our first lesson, the concept of understanding ratios. Hope you learned something. Self-destruct in 10.
Please push the red button. Yeah, that red button. Just push it. Yeah, the red button. Push the red button. Okay, come on. The red button. Push it. You're gonna let it self-destruct? If you subscribe, you're forgiven for trying to destroy the world.